Good afternoon, ladies and gentlemen. This is Jimin Bo from the University of Auckland. Today I'll introduce our paper called HHH, an online medical chatbot system based on knowledge graph and hierarchical bi-directional attention. So I will introduce this paper from 5 parts. So firstly, I will introduce the background. So in the background, we have two backgrounds. So firstly is research background. So the paper is based on the question and answering. And the sub-specific background is this is a medical error singleton question and answering. The objectives and related work of this paper can be found as the following part. So the objectives contain 3 parts. The firstly, we try to reduce the waste resource and unnecessary dialogue time for user. Secondly, we want to predict higher precision answer of symptom. Thirdly, we try to easier to manage and extend the database. The related work can be found like deep learning method and the knowledge graph. Firstly, I will introduce a little bit about the deep learning method. So deep learning method has been widely used in natural language processing area. The main representative methods include the recurrent neural network, long short-term memory, and so on. The main creative idea of those methods is based on the time sequence. That means the previous input words can be used to predict the next future word. Attention had been proposed in 2017, which is very useful to highlight the weight of the keywords from a sentence. And Google has published BERT in 2018, which is also based on attention. Knowledge graph is very widely used in the complex relational networks and have a higher efficiency of relational queries. The main idea of the system of knowledge graph is we can realize the interconnection of things and mine the value of data more efficiently in a massive relationship. The highlight of the project is we combine the deep learning method and knowledge graph. So there are lots of chatbot based on the traditional machine learning method like the logistic regression, naive Bayes, and decision tree. So so what is the problem of this traditional method? So we find that one obvious problem is that many of these chatbots present rules and templates. When users enter a long question, the system cannot really understand the user's meaning very well. So in our project, we try to use deep learning and knowledge graph to better understand user question, and we also borrow some idea from LSTM plus attention and BERT, which can also be used to compare with our method. So in the second part, we'll show some results of our system. So here is some example of our system. Like I have some fever that user, the blue one shows the user input question, and the white one shows the answer that the system feedback to the user. So in the third part, I will show the method about the system. So the key method can be described into mainly two parts. The first is question understanding. So there are three modules. The first is the question classification module. In this module, we use AC algorithm, which is a classical pattern matching algorithm, to help the system to classify the user input question and do the classification. The second module is question analysis module. It's based on the LSTM plus attention to use to help to do the word embedding. And the third part is the query sentence translation module. Cipher query language will be used when we do the user answer searching and semantic answer, especially in the knowledge graph. And second part is establishment of the knowledge graph. We design the entity, property, and relationship in the knowledge graph. So here is a system architecture. So in our system, we have mainly three parts. So we have the client part, we have the server line, we have the knowledge graph, which is a database. And so here is the question and answer framework of our system. So from the top, which is the web interface, so the whole question and answering framework is based on several modules that includes web interface module, question and information retrieval module, and answer and candidate answer section module. The process can be seen as three steps. So the first step is when user type in question, the question module, you can see in the middle, will be used to process the question by using a disease symptom and the instruction and user intention recognition module. So that means the question is simplified into simple and executable query sentence and being transferred into the information retrieval module, which include a medical knowledge base and question answering pair. The candidate answer can be returned to a list by a HBM module, and the final answer can be consist of the top k most similar candidate answer list to return to the user. So in this part, we will show some simple example about how the system works. So firstly, the process question will be transferred into the RDF engine, which is a medical knowledge graph. The medical knowledge graph is used to extract the entity and recognize the intention of the question. An answer will be returned if we can find the exact answer from the medical knowledge graph. So otherwise, the question will be transferred into the question answer pair module, and the HBM module will be used to calculate the medical question pair to find the candidate answer list. So in this case, you can see when user asks question like what symptom of the code. So in our RDF engine, we will do the two steps. The first step is extract the entity. The code is a disease and symptom entity. So the symptom has symptom, so which is recognized by the user intention recognition. So then we will combine with the two output result to combine the two results into the answer selection. So that is the code has symptom. So the final answer could be the fever. So then we return the final answer. So here's the hierarchical by LSTM attention module. So it is proposed to calculate the medical question answer pair similarity. So the basic idea is based on Simon's network, which is widely used in sentence pair similarity comparison. We use Bi-LSTM, you can see in the bottom, and word embedding, and word tension is used to highlight the weight of the medical related keyword. So then the Manhattan distance calculation formula has been proposed to calculate the vector space distance between the two sentences. So then the similarity will be calculated as the final output between 0 and 1. So here's the evaluation part. So I will introduce the data set firstly. So we have two experiments. The first experiment is to compare the HBM with the other two famous modules based on the Crowell duplicate question dataset. So this is a general question pair dataset, and then we need to collect the medical related question pair from this dataset. So we use the medical disease and symptom dictionary to help us to do the collection. So this dictionary I collect from the two famous New Zealand medical website, and then we find about 70,000 medical related records from the Crowd dataset and 1,000 record from this 70,000 medical records have been randomly collected, and positive negative is 1-to-1 as the experiment dates. So the dataset has been divided by 622 for training, validation, and testing. And the experiment 2 is we try to compare the three module in another medical question pair. So the data set is also from another three famous medical website. We collect the medical related keywords as a tag to do the matching, to do the keyword matching, and find the 1,000 matched question pair for each website and to use in the experiment 2. So here's some sample of the Crowell medical subset, and here's the result of the experiment 1. We compare HBM with the two other famous methods, BERT and MALSTM. We collect nearly 70,000 medical related records from the Crowell dataset and train the model by randomly selecting 10,000 records. The proportion of positive and negative is 1-to-1, and the further information can be found in the paper. And here's experiment 2. We evaluate the HBM with BERT and HBM in 50,000 medical question pair for three other famous medical websites and get the highest average evaluation accuracy for each database, for each dataset. Sorry. So the fifth part is the potential market. So this project considers the situation of single-term question and answering dialogue, use the method of deep learning, and combine knowledge graph to present data well. So in the future, the project can be think about to use in the community hospitals or school clinics, which can help patients to solve some common diseases. Thank you so much.